Okay, so this is another wow video. It's part, this one here. So it's like part 284C3K38. It's a series of videos. Line 22f1fa19c3k38. Electro, nanotubes, anode, cathode formula, Zener, Diode, 5G Wow Seti. So this is basically a research and patents PDF files from the keywords is what I found in this video. Okay. So there's the alien radio signal there. Electrolytic capacitor came up. A cardboard enclosed axial led electrolytic capacitors in a 1930s tube radio. So that shows you the old one that they used to have. These are the newer ones, much smaller. Axial lead top and radial lead bottom electrolytic capacitors. And then this is a disassembled 100 UF electrolytic capacitor. So it's disassembled there. So it's quotes from Wiki. Electrolytic capacitor is a type of capacitor that uses electrolyte, an ionic conducting liquid, as one of its plates to achieve a larger capacitance per unit volume. Than other types, but with performance disadvantages. All capacitors conduct alternating current, AC, and block direct current, DC, and can be used, amongst other applications, to couple circuit blocks, allowing AC signals to be transferred while blocking DC power, to store energy, and to filter signals according to their frequency. Although most electrolytic capacitors are polarized, hence they can only be operated with direct current, the large capacitance of electric capacitors makes them particularly suitable for passing or bypassing low frequency signals and storing large amounts of energy. They are widely used in power supplies and for decoupling unwanted AC components from DC power connections. Supercapacitors provide the highest capacitance of any practically available capacitor, up to thousands of farads, with working voltages of a few volts. Two types of electrolytic capacitor are in common use: aluminum and tantalum. Tantalum capacitors have generally better performance, higher price, and are available only in a more restricted range of parameters. Solid polymer dielectric aluminum electrolytic capacitors have better characteristics than wet electric types, in particular lower and more stable ESR and longer life, at higher prices and more restricted values. So my thoughts, I was working on this research originally August 14th, 2012, and today's November 22nd, 2012 when I'm filming it. So I guess this is the formula from the keywords is electric capacitor, ionic superconducting liquid, carbon nanotubes, hydrogen storage, liquid argon gas neutrino alien fuel formulas, which are in line 17 to 22, electron volts of 25 mEh, and storing energy. So more voltages over 500 V, working temps of 85 degrees Celsius, 105 degrees Fahrenheit, high temp use. You need to increase this temperature ability. So I'm going to go with keyword anode, which was another keyword that came up, and there's a graph that came up with it. So quote from Wiki, diagram of a zinc anode in a galvanic cell. Note how electrons move out of the cell and the conventional current moves into it in the opposite direction. An anode is an electrode through which electric current flows into a polarized electrical device. The direction of electric current is, by convention, opposite to the direction of electronic flow. In other words, the electrons flow from the anode into, for example, an electrical circuit. Mnemonic acid anode current into device. Keyword is cathode, and it shows the diagram of the cathode. A diagram of a copper cathode in a galvanic cell or battery. A positive current I flows out of the cathode. CCD mnemonic cathode current departs. Okay. So a cathode is an electrode through which electric current flows out of a polarized electrical device. The direction of electric current is, by convention, opposite to the direction of electronic flow. Therefore, the electrons flow into the polarized electrical device and out of, for example, the connected central circuit. So, cathode polarity is not always negative, although positively charged cations always move towards the cathode, hence their name, and negatively charged anions move away from it. Cathode polarity depends on the device type and can even vary according to the operating mode. In a device which consumes power, the cathode is negative. and in a device which provides power, the cathode is positive. Electroplating metal cathode. When metal ions are reduced from ionic solution, they form a pure metal surface on the cathode. Items to be plated with pure metal are attached to and become part of the cathode in the electrolytic solution. Vacuum tubes. In a vacuum tube or electronic vacuum system, the cathode emits free electrons. The electrons are extracted from metal electrodes, either by heating the electrode causing thermionic emission or by applying a strong electric field and causing field electronic emission. Electrons can also be emitted from the electrodes of certain metals when light of frequency greater than the threshold frequency falls on it. This effect is called photoelectric emission. Cold cathodes and hot cathodes. Cathodes used for field electric emission in vacuum tubes are called cold cathodes. Heated electrodes or hot cathodes, frequently called filaments, are much more common. Most radios and television sets prior to the 1970s used filament heated cathode electron tubes for signal selection and processing. To this day, a hot cathode forms the source of the electron beams in cathode ray tubes in many television sets and computer monitors. Hot electron emitters also used as the electrodes in fluorescent lamps and in the source tubes of X-ray machines. So you got the diodes, anode, and cathode. Okay? You know what this reminds me of right here? You know how it's got the triangle shape there, and then it's got the platform, and we had the core here. If you flip this way, I wonder if this has something to do with that core of the UFO. In a semiconductor diode, the cathode is the n-doped layer of the p-n junction with a high density of free electrons as a result of doping, and an equal density of fixed positive charges, which are the dopants, and that have been thermally ionized. In the anode, the converse applies. It features a high density of free holes and consequently fixes negative dopants which have captured an electron, hence the origin of the holes. Like a typical diode, there is a fixed anode and cathode in a Zener diode, but it will conduct current in the reverse direction. Electrons from anode to cathode if it breaks down voltage or Zener voltage is exceeded. Zener voltage inventions. I'm going to Google to see if there's anything that has this kind of technology in it. So I found a voltage level translator circuit 5691654 from these inventors from Cypress Semiconductor Corp. And it's from 1997. Abstract: a method of limiting or translating the voltages of input signals and of generating output signals such that the input's high state and low state differ by a different voltage than the output's high and low state. The present invention also teaches a system comprising a level translator circuit having level translators controlled by an operational amplifier or by a Zener diode that regulates the voltage level on one side of the translators, the other side of the translators being regulated by an external power supply. The operational amplifier or Zener diode in some embodiments of the present invention ensures that the second side of the level translators are limited to a given reference voltage. Often a resistor is connected to the Zener diode or to the output of the operational amplifier, and in some embodiments a resistor capacitor network removes higher frequency components from the voltage supply. The invention includes a system level embodiment in which the voltage level translators protect a memory and bus from voltage levels that would otherwise cause damage. So that's from pminor.org. Next is a patent application title, Output Stage Having Zener Voltage Balancing. Those are the inventors. Sounds really from Holland or the Europe there. Miscellaneous active electro nonlinear devices, circuits, and systems gating. Parallel controlled paths. 2010 is patent application 20100033230, and it's from www.fax.org patents. Okay, and it shows you there. An output stage, especially a switching output stage for switching inductive loads, having a plurality of individual output stages that are connected in parallel, which include degenerative transistors in the degenerative path of which one respective Zener diode is present. The electric power during a switch-off process can be distributed in a particularly uniform manner to the individual output stages or transistors by disposing the Zener diodes near the associated transistors So they are thermally coupled to the respectively associated transistor, and their Zener voltage increases with increasing temperature. Read more at www.facts.org. Patent application, it's the same patent number as that one, okay? Here's another U.S. patent number, 4562400. Temperature compensated Zener voltage reference, 1985, 1983. It's expired. Okay. Abstract of precision voltage reference comprising an IC chip having a Zener diode connected to the input of an operational amplifier. Variations in output with temperature are minimized by selectively controlling the Zener current in accordance with temperature. The current is controlled by a resistive circuit, including a thermistor, connected in parallel with the Zener. A method of trimming the voltage reference is provided wherein an optimum quiescent operating current is determined based on voltage and current measurements at two different temperatures. And there's the little diagram that goes with it. Patent citation ranking, 7. Okay, I don't know what that means. Analog Devices Inc. from Norwood, MA. International classifications. Total patents. Texas Instruments. I don't know. This bunch of stuff. Here's more inventors here. Temperature compensating voltage generator circuit. I'm not going to read all this. I think this is all the things that you can use it for. Precision voltage reference comprising a Zener diode, an output circuit connected to blah blah blah. Patentbuddy.com. Okay, the invention relates to MOSFET, MOSFET circuit having reduced output voltage oscillations in which a smaller CoolMOS transistor T2 with a Zener diode Z1 connected upstream of its gate is located in parallel with a large CoolMOS transistor T1. So that during a switch-off operation, this is almost done. After the larger transistor has been switched off, the smaller transistor T2 carries a tail current on account of the Zener voltage still present. Okay, so there's the inventors. This is the patent information. So it's a sensitive voltage switch supply circuit for telecommunication lines. So obviously this has there's all sorts of patents and stuff, which it's google.com patents, so that'll be posted with the video. Okay, thanks for watching. I'll go on to the next one. Sorry it was so long.